Hi, today I'm going to introduce to you the quarter sub. The quarter sub is an easy two-part 3D printed model that allows you to demonstrate Archimedes' principle. Archimedes' principle states that the buoyant force of an object is equal to the density of the displaced liquid, in this case water, multiplied by the volume of that displacement and multiplied by gravity. So in this instance we are going to displace water with a combination of 3D printed part, air and coins. Now I've been through a few different design iterations on this, the first one being the small bomb one. It worked, although not very effectively. We then increased size to this one. This had issues with water surface tension. And I've gone through a few other iterations along the way, but I come back to my third one, which seems to be the most robust. Now, this two-part model is made up of a main chamber and a base. Both of these can be printed as is, no support, raft material. Now, there's a couple of different ways that you can print these. The key thing is though that this chamber is sealed. We're going to apply a little bit of pressure to it, so if that seal isn't any good, air will escape and the experiment won't work. So there's two ways that I found works for this. The first way is to print at 100% with 0.2mm layers, and this will work for ABS, which is what I print with. Therefore fairly safe to assume that it will work with PLA. The second method, which is what I'll be demonstrating at the moment, is to use 80% fill, 0.2mm layers with an acetone wash on the inside. So if you're not happy to use acetone, print at 100%. If you are comfortable around acetone with the right safety kit, feel free to do it this way. So these two parts just clip together like that, and a little weight drops into the bottom, in this case US quarters, thus the quarter sub. So what we'll do now is we'll put our quarter sub into the water and we just drop that in there. You can see that it's going to drop and then it's going to come back up. So in putting the lid on, we have closed the system. So at the moment we have a volume of air trapped inside our quarter sub, and this is what's giving us our buoyant force. So what we're going to do is we're going to reduce that volume of air by applying pressure. Now Boyle's law states that by increasing the pressure on a fixed amount of air, the volume of that air will then decrease. So if we give this a little squeeze, what will happen is the sub will start to sink. There you go, and the sub goes back up. Now, I'm not sure if it's visible on the camera here, you might just be able to see it, but there's a little bubble of air that you can see cresting down underneath it. So if we give it a squeeze, that'll push back up and the sub will drop. You can quite easily control the height with which the sub goes to by changing the pressure and changing your grip. And that is the quarter sub. Now, not everyone has access to US quarters, which is what this model is designed to fit around. Reality is any weight will do, but it may take a little bit of fine tuning. Now in this instance, because it's printed at 80%, it carries 2 quarters. If it's printed at 100%, it will only carry 1 quarter. Now PLA is also slightly denser than ABS, so to help with that, what I've done is included a model for a displacement disc. These displacement discs are as they sound, little discs with holes in the middle of them, and what they're going to do is, instead of displacing, they're going to reduce that level of air displaced, therefore reducing the amount of liquid displaced, because ABS is the same density of water or near enough, and PLA is slightly higher. So over here in this one we have a couple of Canadian quarters. These are roughly 1.3 grams each lighter than the US quarters. Exactly the same model as the other one. So what I've got to do is put in 2.6 grams, which in this instance I have a 2 gram or 2 cubic centimetre and a half cubic centimetre disc, and these just easily slip inside. Our base clips on and holds them in place. By adjusting the height you'll be able to fine tune what you require. Now, drop that in and it comes back up. So these should roughly require the same amount of force to drop. There we go. A little bit more on the Canadian quarters. The displacement's not quite right, but pretty close. So if you're having troubles with and have to apply too much pressure or it won't go down, adding those displacement discs will help with that. A little bit of fine tuning does it. The quarter sub.